folks, start working on number 1 there, where you have the bulbs and the batteries, and you're asked about bulb brightness. All right, folks, what do we have? What did you think? B and C brightest in series, D and E less. What about A? What did you guys say? Start to. Voltage is more in series, okay? Thanks for switching pens. I appreciate that. Courtney, what did you guys say? Okay. All right, so I agree that C is going to be your brightest. The student's wrong. And then B, and then A, D, and E are all going to be equal. If you think about it, if each battery has a voltage of V, then the voltage across bulb A is just V, right? And then the voltage across bulb B would be 2V, because you've got the batteries in series, and we know the voltage of the batteries adds up in series. And then C, under that same idea, would be 3V. D would still be V, and E would still be V, because those are in parallel. The brightness is really related to the power, which is I times V. So let's say if there's V across the bulb, that gives us a current of I. What would be the current if there's 2V across the bulb? If there's 2V across the bulb, how much current is there? 2I. From our good old Ohm's law, V equals IR, right? What about the 3V? 3I. And then these would also both just be I's. So, proportionally, the power here is 1. What's the power across bulb B? 4. And C? 9. D? 1. And E? 1. Well, see right here, look. Do you see that equation? What does it tell you to do with the current and the voltage? Multiply. So, that would be the correct ranking, would be C, B, and then A, D, and E all the same. Any questions? All right, let's go over number 2. What do we got? We got all the same. C, and then A and E, and then F, B, and then D. C, A, and then B, F, and then E, and then D. Okay, so you two, you got the grades. Right? All sorts of funkiness. The correct answer, the greatest resistance is C. If we say each resistor has a resistance of R, what's the resistance of C? 3R. And then A and E are the same at 2R, because it has 2 resistors that are in parallel. The next smallest, let's see, B has 2 that are in, sorry, A and E have 2 in series. B has 2 that are in parallel. So what would be the resistance of B? Right, 1/2 R. And F is also at 1/2 R. So E and F are together. And then what's the resistance of D? 1/3 R.
Okay, so if they're in parallel, they're okay. I said series and parallel by looking at it. I thought the ones that were
The
parallel.
physical arrangement doesn't matter, it's the electrical arrangement.
Then how do you know? Like what's the
Is what's supposed to be D?
Like why is there 2 E's on the?
Oh, sorry. That's supposed to be B. This is supposed to be B. B and F.
So like, what's the trick for knowing if it's a series or parallel?
I never think of it really as a trick.
How do you
There's
know?
a single task for series single, and parallel. I think of that they're physically parallel to each other, or there's multiple paths. All right, so we have answers all the same. I'm just looking at A's right now, all the same. BAC, ACB, BAC, can't read it. ABC, BAC, ACB. For it's all the same. This is why you don't have group 3. There's fractional stations. Okay. That's what he's saying, BAC. She is.
Hi, Darby.
BAC.
Why?
Well, we can look at it two ways. I think there's two logical explanations. One is we can look at the resistance the battery sees. In this case, the resistance the battery sees is R. In this case, it's R over 2 or half R, and here it's 2R. The lowest resistance is B, so the highest current. A is in the middle, and C is the highest resistance, so the least current. If you look at it just kind of intrinsically, the current that comes through B can split, and therefore have an easier time going through because it has two options. Each of those options hit one resistor, so a lot more current is going to be able to go through the ammeter before it can split. In A, you'll hit one resistor, so it's going to be less current than the two currents that feed the resistors. And in C, the current has to go through two resistors, so it encounters more, it's going to be less. All right? Hi.
Hi, sorry. I erased my board.
All right, so answers for B. What do we got? CBA, 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 CBA. CBA is correct. CBA. For the exact same reasons as before. Right? R over 2, R over 3. Good. Do you like it? I do too. I'm just getting used to him, looking kind of classy. Let's see, what do we got? I, triple I, increase, triple I, increase, Correct answer? Captain. Because, two ways to think about it. The best way to think about it is the current all had to go through valve A before. Now it has two paths, so less can go through A because some can go through the other one. Now the question is, will the current that goes through A now be exactly half of what it was before? No, it'll be a little bit more than half, because what's happened to the total resistance when you close that? What's happened to the total resistance of the circuit? Has it gone up or down? It went down a little bit, so a little more current, so a little more than half, because now rather than this being R, it's R over 2. So before when the switch is open, the resistance of this circuit, we call it 2R. After it's open, when it's closed, it's now R over 2 plus R, so 3/2 R. It's the total resistance. Good. All right, walking around, look, I saw some good ones. Of course, since these are in parallel with the battery, they're 15 volts. 15 volts, right? Because they're in parallel, and we know from page 13 of our packets, the same voltage. Well, if I have 15 volts across 5 ohms, that gives me 3 amps. If I have 15 volts across 3 ohms, that's going to give me 5 amps. If I've got 3 and 5 amps flowing through here, must be 8 amps to supply that. 3 plus 5 is 8.
So you add them to get the current of the battery. I said 5.
Isn't that what Kirchhoff's junction rule tells me? That the current into a junction equals the current out?
I said 5 because I did like that R2 that were up to the same. That's not right.
Right. All right, what do we have for 6? We have true, correct. Statement is correct. True. You guys did true also? You said false? You said true. Hold on. Gentlemen, stop. Yes. What does page 13 say about these things in series? Constants, the same current. So it's false.
But it's the stuff before. There's the stuff before, and then everybody's right until they start to talk about right?
Correct. Yes. But he is wrong because they have to have the identical current. What do they have that's different? Voltages.
So they're in series and they have identical current.
They have to. There's only one path for the current to go through. So the student is wrong because they have to have the same current. Josie brought up a good point. What relationship is R1 to R2? What relationship is R1 to R2? Nothing. What about R2 to R3? Nothing. R2 to R4? Nothing. R3 to R4? They're series to each other. So what we could do also, we could combine those two, right? And get a new circuit. So we could get a new circuit that looked like this. And it would have some combined resistor. Let's see, what was this one? This one was R2, this was R1. This would be some combination of 3 and 4, right? Now, what is the combination of those two? How does that relate to R2? That's in parallel. So those two could be combined, right? And we could keep reducing our circuit down. So now we'd have R1, and we'd have some combination of R2 and 3 and 4 all together. And now what are those in? Series. So now those could be combined into, and I'm getting really slanty here, I don't know why. After yesterday's discussion, you should know how to do this. Maybe it helps to understanding. But you can combine them all down. So, good question then. But it comes down, now the question, which students are correct, if any? You like Efrins? E's? What else? Courtney, what do you guys say? Oh, that's not what you meant.
What just happened?
The correct students are AJ and Efren. AJ and Efren. Do not judge people based on their name, Luke. Let's look at number 8. What do you got? I see C and E. E, C and E. Alec? C and E? C and E? Correct answer? C and D. C and D. E is not correct. Right. R2 is not in parallel with the battery because R1 is in the way. If I took off for every student that hedged their bets, we wouldn't have any correct answers. So, 9 and 10 are your homework. I will be checking them not only for completion, but for correctness. 9 and 10. It'll be 10 points each. 5 for if did you do it? 5 for if you got it correct. There you go, Gabby.